Welcome to the assembly video of the 3D printed smart LED wall panel. If you're interested in this project, definitely check out my main video documenting the whole design and build process. I'll link it in the description down below with the links to the products that I used and the 3D print files. This video is dedicated to the assembly process, so you have a step-by-step guide if you want to build this project yourself. Let's first check out the materials needed for this project. For the LEDs and the cables I went with BTF Lighting, a very well-known brand for their high-quality LEDs. I used two 5-meter BTF Lighting WS2815 12-volt LED strips, and most importantly with 30 LEDs per meter. For soldering and extending the LED strips I used BTF Lighting 18 AWG extension cables, some Goubet soldering tin and some generic flux from Amazon. The controller is a GLED Opto GLC015 WLM with a generic brand 6 amp 12 volt power supply. For gluing the 3D printed parts to the backplate I used Uhu Alleskleber. This is a type of all-purpose glue. The backplate is a aluminium coated composite plate called LU panel with a size of 104 by 37.5 centimeters or 40.95 by 14.76 inches. You can shrink this down by a few millimeters to get some nicer cutting dimensions if you want to. If you do, just make sure that there's enough surface left for the glue to adhere to. For the filament I used two types, but the Bamboo Lab Basic and Matte are very much the same except for the finish. And you need just under 2 rolls with a total of about 1.7 kilograms to print everything. And that's it for all the materials that I used in this project. I printed this nice little template, snap it together. And the idea is you put this on here and you can mark where the LED strips will be lined up. So you can just move this along the side and mark wherever you need. I'm just going to do 5 intervals. That should give me enough markers to have a right guide. Here is where the visual representation might not completely line up with the steps of this assembly. This video takes you through the process of how I would do it again if I did this project again, which is way better. I took 4 months from design to finish with several issues and serious steps that I had to redo, and unfortunately not all were completely reversible. You don't have to, but I would highly recommend watching the longer complete build video to maybe avoid other headaches or bigger mistakes that I also made. Here's a quick example of what I meant by that. It's probably best to execute this step now. I forgot to drill a hole in the backplate. For this assembly video, you can trust the video steps and you'll be good. This is a 10mm cobalt drill bit, designed for metal I think, but it works really well on these aluminium panels. I measured 10 centimeters from the top of the base. This put me right under the space in the C1 piece for the screw head. But I also made a template that you can print, ledge onto the edge of your base and mark where you need to drill. You'll have the perfect distance from the edge, just make sure that you're centered. And you can also use one of these. These don't line up completely, but I mark both ends and then take the center from those 2 lines to make sure that they have the proper center. So we can now mount the piece as well, which is very handy. And these are all the parts that we need. We have the panels that will go on the front. This is one side, this is the right side. These are all marked. I'm still working on marking for the panels. These are listed R1 until R5. So it's very easy, it all goes together. I'll throw up a schedule here somewhere, just a schematic for reference. So for example, this top piece, it's T1 and T2, and when connected it might seem odd, but everything is designed that when the design meets up, looking from top to bottom to the finished product, it's marked down below. So T1 is now on the left and on the right, so left to right it's 1 and 2. That's just how I like to do my designs. Yeah, to keep a process that's consistent throughout my projects and to keep everything in order. So when you're looking straight at the piece, everything is marked from left to right and numbered accordingly. But when you are assembling it, the numbers are on the bottom and therefore mirrored or flipped. But I will also make sure that that's visible in the schematic as well. So we have the right side, left side bottom will also fit the controller with an additional piece that snaps into it. So we'll do that when the controller is seated. And then we have some bridges that connect the center to the borders. So this will be in the center of our grid or panel matrix. This is something that these panels will slide along and follow the track from top to bottom. And then we have the top pieces and the bottom pieces, which are 2 individual pieces. So those are all the pieces that we need. Everything's designed to go together like Legos. It's fairly straightforward. I'll provide a schematic as well, and it should fit on our backplate. So I'm going to start off with the right side. These are all interlocking pieces, so you can slide these and they should snap together. You can make sure that they're flush. Sometimes they go a little bit too far because you feel the layer lines shifting. Now we have a nice flat surface. And we can continue with the other pieces. The borders are supposed to have a tighter friction fit. They provide rigidity to the frame and have to align to make the panels slide smoothly. So this is our right side. And there are some small notches here. These are for these spacers, and these will make sure that we have the right distance between the right side, center and left side. So these are a bit finicky. This is the least proper connection for me, I think, in this whole project. You have to clamp them in there. So there's a certain reason why they are so shallow and a bit finicky, but they work, and I think it should be fine for everybody. Might be a new iteration on that in the future as well. So I'll put these all in for the right side. And that's one side done. Now there's a distinct difference between the top and the bottom, and the bottom has these larger connectors and the top has this smaller connector, and that's for the following purpose. We have these over here. They are oriented that if you have the top piece, can snap these together as well. Make sure they're flush. So this top part should be removable in the end. Oh, I don't know if that's visible, but this top part should be still removable when the design is finished. So you can remove these panels, you can just slide them out and place new panels in there. So you have more designs available. For this demonstration and assembly guide, we just use these panels. These are the most basic ones. For the center, we have C1 to 5, so center 1, 2, 3, 4, 5, and they go on there accordingly. So these also have a nice little connector. You can just Connect these, and we can continue that. So C3, they can only fit one way, so there's no mistaking it in which direction they have to be. You might have to wiggle those centerpieces a bit because they are tight tolerances, and sometimes it's just, with the printing tolerances they can vary, or there's some shrinkage or something because of cooling or removing it. It's not really strict, but in the end they should all match up very nicely. So when connecting all the centerpieces, I noticed, I don't know if this is visible, but there's a little bit of bowing when connecting everything together. And I think that's because either the connectors in the bottom, those tiny pins, might have shrunk or displaced a little bit, or this top connector is a little bit too beefy to socket into the other one. So I will tweak that further before the final version will be published. I was able to remove the bow by letting some books rest on it overnight while gluing, but I've tweaked the final design to have a less tight fitment. And in these centerpieces we have these sockets, and they are for the spacers from the border pieces. So these will just, let me disconnect this one for a moment. These will just fit in there, and they stay as well. So everything should be all together before you start gluing or permanently mounting something. You can also check that the tolerances on the LED strips are fine, because these are bridges that also have space for the LED strips. They are about 5 to 6 millimeters, if I remember correctly, so they should provide enough space for basically all the LED strips, with or without the silicone sleeve or whatever LED strip that you use. I didn't find any that were thicker than that. So these will be seated like that, and from both sides there will be a spacer connected. And these should also be fairly easy to remove. So I spend a lot of time on the tolerances and the fit, and I hope it prints nicely for everybody. But yeah, I also tested different filaments, matte filament, PLA, because there's a difference in how tight or how strong they grip into each other. So that's why some of these interconnections between the top and bottom might be more tough than the outer connections, because we want the top to be removable and the bottom stuck solid. So there are tiny differences in those tolerances as well. So we have our right row, then I'll assemble the left row. L1, L2, L3, L4, and the final one, L5, is a little bit special. This has the spare part for the connector. This hole is for that black cable of our matrix grid. I don't know if it's still in view. Let's see. For this cable to go through. So this is the left side, and this is the bottom one, number 5. And this cable has to go through that hole, and it will go up into the controller. Let's take a look. The controller that I'm using has this cable. I took that measurement and added a few millimeters to that. So this cable should be able to flip and be upside down in this wall. And there's plenty of space for our adapter cord to go into the controller as well. And you can flip the orientation of the controller, that doesn't really matter. You can look at this socket, which on top would be preferable, I think, because it leaves you more space for this one. But that's up to you, and you can connect these beforehand. There's just one more piece to that, and that's this one. This is the snap-in end. This will make it look all nicely when it's on the wall. It gives it a more finished look and prevents the cables from falling out. There's a second hole so you can really put your fingers in there and pull it out if it's too stuck, or if you want to replace it or have to access the controller. Because with only the hole for the cable, it was quite tough to get it out because it's not in the center, and yeah, you're just pulling on one side, so the chance that you break stuff is more apparent at that moment. So that's why this piece is separate, and when there are two holes, you can also provide another cable to it if you have a different power supply, for example, because I use a preset adapter. But if you use stronger LEDs or you have extra power to the LEDs, you can run it through there as well. I just wanted a nice and clean look that when it's on the wall, you have one cable going on the side in the left bottom corner. So let's connect the final piece of the left side. So that's the left side completed. Flip it around. Put in the spacers again. That's one a little bit loose. I have to check that one. This is the one with the controllers. So this is the newer version. Cable pass-through is larger, and I fixed the tolerance on the snap-in-place connector for the spacer. It got messed up somewhere and the opening was too high. This one might hold, so I might encourage it a bit more with a dab of glue or something, maybe later. But the other ones all snap in nicely and they stay put. Now, let me put this one on this way. Okay. And there's one more thing to keep in mind with these top and bottom pieces. It goes for both sides, although I don't think that one will work because it has a different orientation. But for these bottom ones, they can snip together in the wrong orientation. So now there's nothing numbered or referenced in the center, because these are the outside connectors for the walls. So I'm going to flip them, and there's a smaller slanted edge in the center that snaps together. And there's also the space where these ends, the C1 and C5, they connect with these border pieces. And there's a spare out for cabling, for if you have the cable running between LEDs, that has to go through there. So that's why these two are also notched on the outsides and the other ones aren't. But that's something to keep in mind as well. And the reason why these two are opposite is because we have the controller box here. So I had to change up that design in opposed to the other connections. So yeah, that's why some things fit only in one way, or it's just a little bit nuanced. You have to look at what you're doing. So I'm going to tweak these center pieces a bit, and when I have them flat, we'll place those as well. Probably can do this way easier by moving everything to the side, put center in place. And the spare out in C1 is for the screw or something that's there to hang your wall out. to just aim the spacers and put them in. So I just click in the spacers from one side and then I'll do the other side as well. Doing this again, I would start with the left border, the one with the controller spare out, and hook in the bottom border piece first. Then place the center piece and snap all the spacers from the left border into the center piece, and then you can connect the right border with the bottom piece and snap all those spacers into the center part as well. These connections all sort of stack in that order. And here's another prime example of those lessons learned in action. I tried to do it the other way that I tried the first time, and spacers snapping out and so on. So yeah. And this is the last one. This is the top piece. For the rest we can just connect these as well. It will just snap into place and slide on there. So this is everything connected together without the plates inserted. So this should be a fairly rigid structure as well, as you can tell. And this is what we will mount with some glue, except for the top pieces, to the backplate. So there will be 3 sides and the center will be glued up in the end. And if we remove the top, this has a looser fit to be removable as well. We can then slide these panels. We can slide them into these grooves. You always have to look at the orientation because these aren't numbered yet. And they should be able to slide all the way down. And for now there's a reference on these pieces. There's one side that has an edge and it slides into the next. So that's how I reference these now. I do want to make something of a notch that lines up throughout one side to reference which piece goes where. So I've designed a method to identify the sides that shouldn't disturb the light effects from the outside. I've created these small indentations on the bottom side of the grid panels. One side has a cube cutout, the other side has a triangle cutout. The shapes should form some sort of an arrow pointing to the center. It's not ideal, unfortunately. I've tried other options as well, like tabs or numbers, but they disrupt the light, are a one-time use that you have to remove, like some small tabs with a number, or are just a nightmare to print. This was the cleanest solution that I could come up with for now, and it only uses less filament. The left and right side are the same, so it doesn't really matter if the cube or the triangle side is on the left of the or the right side of the panel. Now all the panels are fitted, it's time to place the top piece, final piece, and we'll see if everything goes together and stays together nicely. It's a bit finicky because not everything is glued in place, so things are moving a little bit all over the place. And that's our grid completed. Should be able to move this as well. So this is a final standalone grid that will be mounted to our LED panel. I can show you the back side as well. These are all the pieces and the spacers and so on. Now let's plug it in and see what happens for the very first time. So if you're yelling at the screen or thinking at this point, I cannot do that yet, you would be totally correct. This is something which you cannot do yet. And that's a good thing, and it will prevent you from making this mistake. My cables are too long. I would have to resolder half of all the solder joints, which I'm not really looking forward to. And this mistake? I used the wrong LED strips. If you want to prevent making these same mistakes, now's your chance, and you can still check out the main video and see how I discovered and solved these issues. So now that we have our backplate prepped and marked, our 3D printed parts dry fitted, and we know everything works, I suggest you cut, glue and solder the LED strips into place onto your backplate. I can guarantee you that this will save you many headaches, swearing sessions and most importantly, time. You can also test fit cable fitment and the LED placement before permanently gluing stuff in place. So the idea is that we have two of these 5-meter rolls and we're going to cut them in 1-meter strips. So we'll have 10 pieces of 1 meter. That will all be lined up next to each other, so we can get sort of a matrix of LEDs going on. These are the LED strips, and we have to connect those on these ends. So the first one will be connected to the controller. And the controller will be connected to the PSU or the power supply. And this will have a cable to the net or extension cable or to the home. So we'll loop these all together. In the end, we should still have one long LED strip. We have the first LED here. This is number 1, so it will go to 30 until the end. That's 60. We have to make sort of a matrix that for all of these, they are in the same direction. I highly suggest you at this point test your controller and LED strips to make sure everything's working before we continue. You can then cut your 2 rolls of 5 meters into 1 meter LED strips. And only leave the first connector from the first LED strip to connect to your controller. I did strip the sleeve of this one to make it more pliable and easy to work with. I will be using the backing that's on the LED itself. It has its own adhesive. I'm going to make sure that I have the same spacing on each side for the cable. I'm going to start at the left bottom corner and stick every strip in its right position. Another important lesson in time management: start at the controller. Just saying. I'm just going to aim for the center of the LED strip. I don't have a clear shot of this unfortunately, but I aim for it to put the center of the LED strip on the marked line that I made with the pencil. And you won't be having one long LED strip soldered together already, so it should be a lot easier to place these LED strips as well as lining them up. And while doing this, keep in mind to change the direction of the LED strips on each row to achieve the serpentine pattern that we need for the matrix. The arrows on the LED strips have to go from the controller all the way to the end. You can then cut the appropriate cable lengths and solder the LEDs into one long strip. I separated all the wires from the 5-pin cable so that there was less tension and I could create more compact loops towards the next strip. While doing this, try not to obstruct the openings in the top and bottom borders too much. They are designed for the hot air to travel up. This way it should provide some convection cooling by moving cold air in from the bottom and going over the LEDs and then venting the hot air out at the top. Then hook up your controller to test the LEDs and to admire your LED grid for the first time. Now with everything soldered, we can do another dry run to see if everything fits in place and if we have enough spacing for the cable now. So let's take our 3D printed parts and this is the right side, so it should be like this. I'm going to take out the plates. This is exactly where the cable should be. Both sides look awesome. Even the connector bridge here between the center and the top pieces is fitting very nicely. And this is fitting nicely on the back plate where the hole is for mounting it on the wall. So we can do two things now. We can apply glue to the back plate or we can apply glue to the frame. And it will probably be a mess either way. So the frame being on top, I would prefer putting it on the 3D printed frame. So let's flip the grid around and glue it into place. Now for the glue up, we don't have to glue the top side, we can glue the bottom pieces, but I don't know if I would do that. And for the center, it has been sitting like this overnight and even the bow is gone now, so it was even flat on the back plate just now, so that's also settled itself very nicely. So I'm going to use this glue. This is some Alleskleber. You can use all-purpose glue, CA glue, just something that sticks PLA to your back plate of lighting. And I'm going to try to apply it a little bit more towards the inside of the piece, so that if there's a squeeze out, it will be on the inside and not the outside, just for visual purposes of the end result. Alright, now the most crucial part, flipping everything around, not placing it in between spots or on LEDs with all three parts at the same time. So you could do this in steps, looking at the connectors and how to, what's the proper order to let things go together. I would want to try this in a single try just because of ease, and everything will be in place at the same time. So that's my reason for doing this like this, but yeah, do it your own way, what suits you best. Let's move everything over first. And what's very nice is that because this whole structure or frame is quite sturdy, as long as you make sure that the borders on the outside line up with the back plate, everything should just fall into place. Keep in mind the cable. And place it down. I'm just doing a visual checkup on all the parts, making sure the spacers are in place, that everything lines up, especially on the borders. This spacer got out. And these are all fine. So even the center is holding down pretty well, but I'll put these panels on there to just keep it down for a moment. I'll let everything dry for an hour, 2 hours, and then I'll be back and we'll continue. Almost done now. Let's wire up the controller. I use this extra cable to help me tuck everything into the border. This is an extension cable that I got with the LED strip and it has the perfect length. I snipped off the extra cables, connected it to the LED strip and into the controller, and I tucked it behind the controller in the border. This gives you just that extra space that you need to loop the cable around. And there's plenty of space to tuck it away. And let's not forget our nice snap-in-place cover plate. I like to put the adapter cable through the most bottom hole first and then plug it in, and you can then snap the cover in place as well. Now it's time to put the panels back into the frame and to hang it on the wall. And plug it in, fire up WLED and throw on some effects. And then of course there's only one more thing left to do, and that's to like the video and subscribe to my channel. And let me know what you think of this project. And go admire your hard work and enjoy some awesome LEDs.
Two androids dream in color. Two androids dream in color. Silver dust on broken rails. Artificial daylight pale. Every room repeats the same. Still your voice cuts through the haze. Tiny hands against the screen, searching for what words could mean. Like the world was left behind before you got the chance to try. Maybe being alive asking why.